Hi everyone, welcome to Building with the AppSheet series. I am Pooja Jain. I'm a Google Cloud Customer Engineer on the Google Workspace team. Today we are diving into how to work with data in your AppSheet apps. From this video, you'll learn how to use various data sources in your AppSheet, how to structure the tables, column types, and use different virtual columns and keys in the table. You'll also see how to make slices to a table to filter out some part of the data. You'll see how the references in the table work, and we'll end the video with the demonstration of all the concepts we have talked about. AppSheet supports various types of data sources. They can be grouped into 4 categories. First, native AppSheet database. An AppSheet database is a first-party, native data source for organizing and managing data powering AppSheet apps. It provides an easy and efficient way to build data models for any AppSheet app without needing to use an external data source or databases. Second, spreadsheets that include Office 365, Excel, Google Sheets. Third, databases that include MySQL, PostgreSQL, Microsoft SQL Server, Oracle, BigQuery, on-prem databases, etc. Fourth, other data or provider services like Google Drive, Google Calendar, Apigee, Smartsheet, Dropbox, Box, and Salesforce. Note that you can add data from multiple sources, for example, Google Drive and Dropbox together in the same app. All data sources in your account are available when you add tables to your AppSheet app. You can connect AppSheet to your data in a few ways. First, you can go to your app and look at the data section. From there, you can connect it to a new data source by clicking on the plus icon here. It will show you a couple of different options which we discussed earlier, such as the AppSheet database, Google Sheets, Google Forms, or even an external data source such as Salesforce. The other option would be to go into the My Account section and clicking on the account settings. From there, we can see the Sources tab, and from here we can add a new data source. Note that data from multiple sources, for example, Google Drive or Dropbox, can be used together in the same app. And third, you can go to your Google Sheets and you can connect your data to AppSheet directly from your sheet by clicking on Extensions and AppSheet and clicking on Create an App. After you have created, connected, and configured your app to use your data source, you then need to define the data structure in your app. AppSheet is a data model platform. What that means is that you should have a data source of some kind before you start building out. A table is a collection of records. You might have an appointment table like this, or a task list, or a jobs side table, or a products table. Think of tables as simulating things in the real world: people, objects, location, events, etc. Okay, we can take a look at an example in the AppSheet. So I have a task list AppSheet app. I can go ahead and take a look at the data pane here on the left-hand side of the navigation bar, and it opens up existing tables here. The data pane is displayed, and the first table in the primary navigation is opened in the editor. Here we can see a bunch of things you can do with the table. In this case, my table name is Owners. So if I wanted to manage my table, I can click on the 3 dots and see various options here: renaming the table, deleting the table, and viewing the data source. There are more options here. By taking a look at the top 3 dots which says More, there are more actions that you can take on this table, such as creating a report for BigQuery, deleting the report, or previewing the data. It opens up a separate tab that previews the app. We can create a new table by clicking on the plus icon here, or adding a new slice, which we'll talk about subsequently, by clicking on this plus icon here to add a slice to this data. Now, every aspect of your app depends on the data hierarchy, and the hierarchy originates from the table itself. So you will find those settings by going into the table settings by clicking on the settings gear icon on the top right. Any settings you create on the table section, they trickle down to other aspects of the app, down to the columns, slices, views, actions, etc. So here I have a table named Owners, which I can change from the section. But if you notice here, I've given permissions such as updating, adding, or deleting records to this table. If I only made this read-only, users can't take actions such as updating, adding, or deleting on the table because at that table level, you have restricted that to be read-only. So this is how you can inform how you architect your app as you make or prevent a lot of changes from happening at the higher level of the app without needing to microcontrol AppSheet attributes at a lower level. There are other settings in this particular navigation that we can see here from the settings page. Here I can see the source of the data. For example, here I have a Google Sheets. The name of the sheet is task list. It's taking the data from there and the tab name is owners. And the source of the data is Google Sheets and so forth. If we actually wanted to see the data source, we can go ahead and click on the data source here and it opens up a separate sheet which shows me all the data from where it's coming from. This shows me the email, owner name, and the various other column names which we will discuss next. From table, let's move on to the column structure. AppSheet automatically infers your table column structure, including the name, type, and other column attributes for use by the app based on the data source you have connected your AppSheet to. You should review the types and other settings of the columns that have been automatically set and feel free to change them if required based on your app's requirements. Let's take a look at the columns in our app task list. I'll navigate to the data pane on the nav bar on the left-hand side, which opens up the table. Here, we can see the various columns in this table and we can change the settings of the column attributes. Starting off, the name. This attribute is automatically populated from the name given to the column in your spreadsheet or table. Type. This attribute determines the data type of the column and is based on the data that is given in the column in the data source. For example, if you have a column named due date in your connected spreadsheet and the values there all look like dates, AppSheet will assume the column is of the type date. The editor often correctly identifies a data type, but if it doesn't, you can change it using the drop-down. There are over 35 different data types and we expect this to grow. The choice of data type affects the behavior of this field in the app. Some commonly used data types are date, datetime, which indicates the value in the column is a date or a datetime. Enum. Enum is essentially a drop-down list. It allows users to select one or more values from a list of values. The other is enum list. It allows users to select 0 or multiple values from a drop-down list. This is helpful in case when you assign more than one value to a particular column. Few other values are email. This indicates the value in the column is an email address. Other common one could be address. Address is used to specify a postal or a street address. Values of type address can be plotted on a map in the app. Using a complete address that includes a city, street, country, and postal code values help ensure that AppSheet geocodes it correctly. The other popular one is image. It indicates that the value in the column is an image. There are various other data types and columns that can be used in AppSheet and they're provided in the documentation in the AppSheet Help Center. You can also set the following column properties. Key. You must have a key column that uniquely identifies a row in the table. Its value must remain constant. The key may be a single column such as email or 2 or more columns such as email and name. Each row in the table must have a key value that uniquely identifies it. In other words, no 2 rows in a table may have identical key values. This is critical because it allows AppSheet to reliably find the right table row. When you update or delete a row through an AppSheet app, the key is used to find the row to update or delete. Sometimes you might want column values to be computed automatically in the app while the user is interacting with the data in a form. You can make a column computed by configuring it with an app formula or with an initial value expression. Columns with app formulas are useful for values that should always be computed when a form is opened or when a row is modified. For example, if you have the first and last name in 2 separate column names, you can create a formula to concatenate both of them together into one owner name. Instead of having a formula always be recomputed every time you update an app, you can set initial values for any given field in your app, which you can override later. For example, while adding a task to your to-do list, you want that the app should automatically get the time at which the task was logged and add that to the app. This can easily be done by using a formula expression in the expression assistant. In this case, I'm using the formula now, which automatically gets the time at which the task was logged in the app. If you think that the task would have been logged at a different time, you can go ahead and actually override the value in that field. These values are only computed when adding new rows, not when updating existing row. Let's take a look at few other column properties. The label property. It enables you to choose the most important columns in your table, and it indicates that the value of these columns will be displayed in the app primarily. In our example of the task list AppSheet app, we have chosen owner name as label and photo as label. What that means is, if you take a look at the UI, the photo and the name values are being displayed in the app as the identifying labels of the record. The show property allows you to display or hide the column data in the app. The editable property lets you enable or disable the user from editing a column's value in the app. The require property forces a rule that the column must have a valid data in all the rows of the table. Occasionally, AppSheet will add virtual columns automatically to your table structure. Let's see what these are. Virtual columns are automatically added when a table is first added to the app or when the table structure is regenerated. A virtual column is a column that doesn't correspond to an actual column in the underlying spreadsheet or table. Instead, it is a column whose value is automatically computed via an app formula expression. Sometimes virtual columns are system generated and you'll see them show up in your column structure. Examples of automatically added virtual columns are row numbers, which compute a unique number for each row. Another common use case for virtual column is to combine other columns in the app. You can combine the first name and last name columns to construct a virtual full name for display in the app. To implement this, you can use the app formula concatenate first name, last name. You can also use virtual columns to construct complex conditions using app formulas that operate on real columns in your table. Let's learn about references between tables, when to create them, and how to use them. When an app uses multiple tables, it's often useful to create connections known as references between the app's tables. For example, in the task list app, which we have been working on so far, it might contain following tables: an owner table with one row per owner that contains details of the owner, and a task table with one row per task. Each owner's row will reference a row in the task table for the corresponding task. When a reference column is created, AppSheet automatically creates a reverse reference virtual list column in the reference table. For example, when you add reference column to the owner's table that refers to the task table, the system automatically generates a reverse reference column to the task table that references the owner's table. Note that this reverse reference column is virtual and will not exist in the underlying sheet or table. References serve multiple purposes. They allow you to represent relationships. The reference between task row and owner's row allows you to capture the relationship between the task and an owner. They allow you to easily retrieve information from a related row in another table. They also allow you to navigate from one row to another. Let's talk about data slicing. When you show the contents of a table in your app, sometimes you don't need to show every row, every column, and every action. Instead, you can slice the data, choosing to show only a subset of the rows, columns, and actions. It's important to note that a slice does not need to have all the components of subset of rows, columns, and actions. Rather, a subset of just the rows or just the columns or actions are okay. Slices are most useful when you want to create a view for a part of the table. For instance, you might have a list of tasks in various status, but you only want to display only those tasks that are still pending. So a slice will come in handy to filter out all the tasks except for those that are incomplete. Building slices is very easy in AppSheet, as the Slices editor pane allows for quick construction and immediate testing, all without requiring any code or knowledge of SQL. Remember, once you define the slice, you will still need to use this slice in the UX view, which we will shortly see in a demo. Let's see a demo of using data in your AppSheet app. Let's return to our task list demo application from prior episodes and extend it further. Let's come to the data pane from the left nav bar. We see that we have two tables, owner and task. If we want to take a look at the data source, we can click on the view data source here that takes us to sheets that's powering that application. It has the task information and it has the owner's information. In the image column, it has the location of the file containing the image of the owner. Image columns can also contain publicly accessible URLs to the images. We can start customizing the app now. You're in the data section of the AppSheet editor. The app preview shows the owners from the sheet. I can click on a particular owner and I can see their respective tasks. Let's examine the table structure of the table owners by clicking on the data tab in the editor if it's not already open. Note that AppSheet has inferred the column structure from the data rows and header in the Google Sheets. Note that email column is identified as the key column, indicating that the values in this column must be unique across all rows in the table. The underscore row number is a virtual column that does not correspond to an actual column in the underlying spreadsheet. Typically, automatic virtual columns are added when the table is first added to the app or when the table structure is regenerated. These column structures are added as a convenience based on the common use case. You can control which columns to display in the app by selecting the Show attribute of the column. We've discussed other columns previously in this video, so you can refer to that. We also have AppSheet documentation if you want to further read the description of other column attributes. Let's see the task table. Here we have the underscore row number, which is the virtual column, a task, priority, due date for the task, status of the task, and owner field. Notice that the two tables are connected to each other. AppSheet allows you to create these relationships with table references. Here we have a column owner, which is of the type ref. It is automatically getting reference to the owner's table. If we go and take a look at the owner's table, here AppSheet has automatically created a reverse reference that is reverse referencing the owner table. Now let's go ahead and make some changes to the app. We'll introduce a new slice that will allow me to filter some of the data results that I see. In this case, when I click on the task view, you can see all the tasks. But let's say you only wanted to see the task by your task ownership and only those ones which are not complete yet. Basically, filter out any tasks that have already been completed. So let's go ahead and do that. For that, I'll go ahead and click on the plus icon next to the task table that says Add Slice to filter data. Here it gives me some suggestions which could be time saving, but in this case I'll just create a new slice from the scratch. So I'll click on the create a new slice for task. I'll give it a name, my tasks. Moving on to the source table, I'll base it off of the same source table, which is the task. Next, I'll go ahead and I'll set up a row filter condition. As discussed previously, there are other options such as slice columns or slice actions, which we could specify in the slice. But in this case, I'll go ahead and accept the default values, so I don't necessarily need to override or change anything here. So for the filter, I'm going to have a row filter condition. I'll go ahead and create a new expression here that allows me to specify that I only want the tasks that belong to the current user. I do this by adding this one little check here, and the green check symbol tells me that this has been validated to be correct formula. This formula says that the owner column has to be equal to the same currently logged in user that matches their user email. So I click save here. and I click save here at the broader save operations. So you'll notice you'll still see all the tasks here. So what do we do to actually see the change? So in this case, we're looking at the main task view, which is still referring to the original data source. So we need to replug it to the new slice data that we just created. I'll go to the views pane in the left navigation bar and click on the task view. So as you can see here, for this data, it's referring to the task table, which means that I need to change it to the slice we created here, which is my task. I'll also update the title here. So from here on, we're going to call this my task, and we'll hit the save here at the top right. We can see our updated UI. It has my task name for the view, and it has just the list of my task in it. I can verify this by going to the source spreadsheet and checking the list of the tasks assigned to me. I see I have 4 tasks assigned in the data source as well. Now I want to restrict it even further so that only the non-completed tasks show. So anything that's complete, I don't want to show that. So to do that, let's go back to the slice definition by going to the data, clicking on the my task slice here. Here we'll update the row filter condition to add an AND operation here. The AND function allows us to evaluate 2 expressions together. For this one, we need to set the status to not equals complete, and I close that off with brackets. So now we have an AND function that puts 2 expressions together and evaluates it together. Let's save it here and then save it at the top right for the broader save operation. There you have it. Once the app syncs, we see that all the tasks which are complete, they're no longer there. So just in a few steps, I was able to create a slice to give us the desired behavior to filter down to only the tasks which are in progress status and belong to the user who is logged into the app. This concludes the demo on working with data in AppSheet. For more information on AppSheet, Google Cloud, and Google Workspace, check out these links in the description below. And for more videos like this, make sure you subscribe so you don't miss out. As always, thanks for watching.